We are living through one of the most incredible, most revolutionary times in the history of science. Right now, a whole new generation of unbelievably powerful telescopes is peeling back the layers of the cosmos. And it's showing us a universe that's more beautiful, way more violent, and honestly, a lot stranger than we ever imagined. Just look at this. It's this violent, chaotic, and just absolutely stunning scene from the outer edges of our own galaxy. And what you're seeing here, it's actually a clue to one of the biggest questions in all of astronomy. So in this explainer, we're going to chart a course from our own cosmic backyard all the way to the very edge of what we understand. Astronomers are calling this a new golden age. It's an era that's really defined by technology that is giving us a completely new set of eyes on the universe. We're not just seeing farther out, we're seeing with a kind of clarity that, not too long ago, was pretty much unimaginable. Now, this golden age didn't just pop up out of nowhere, right? Its foundation was laid by legendary instruments like the Hubble Space Telescope, which for over 3 decades has given us one breathtaking image after another. But the tools that are coming online today, well, they represent a true quantum leap forward. And this right here illustrates that leap perfectly. On the left, you've got a beautiful Hubble image of the Butterfly Nebula. Gorgeous. But on the right, that's the same nebula as seen by the James Webb Space Telescope. Just look at the incredible new detail in the gas and dust, all the structures we can now see inside those wings. We're not just getting a prettier picture, we're getting fundamentally new information. So how is this even possible? Well, telescopes like Webb and Euclid are designed to see in the infrared spectrum. This lets them slice right through the cosmic dust that would normally block our view, revealing these hidden nurseries where stars and galaxies are born. It's kind of like having astronomical X-ray vision. With these new powers, let's start our journey close to home. You might think we've got our own solar system all mapped out, but these new observatories are finding surprises right here in our own backyard. Okay, take Uranus, for example. The Voyager 2 spacecraft flew by it almost 40 years ago and gave us our first real close-up look. But just recently, using the James Webb Telescope, astronomers spotted something that Voyager missed completely: a tiny, previously unknown moon. And what's just wild is the scale here. This new moon is only about 10 kilometers across. It's a cosmic pebble. Finding it just goes to show that even after decades of looking, our own solar system still has secrets, and Webb is powerful enough to sniff them out. Now let's step just a little further out, a mere 55 light-years away. There, we find another fascinating world called Speculus 3b. It's an exoplanet that's almost exactly the same size as Earth, but it orbits a tiny, ultra-cool dwarf star. Discoveries like this are helping us understand just how many different kinds of planets are really out there in our galactic neighborhood. All right, now we're going to zoom out even further into the vast expanse of our home galaxy. The Milky Way is just filled with these epic cosmic events, and for the very first time, we're getting a front-row seat to the birth of its most powerful residents. Hey, remember this image from the beginning? Well, this isn't just some pretty gas cloud. This is what's called a protostellar jet, a colossal stream of gas being blasted out into space at supersonic speeds by a single massive newborn star. And just to give you a sense of scale, this jet is 8 light-years long. That is nearly double the distance from our sun to its nearest star, Alpha Centauri. It is an object of almost unimaginable size, and it's all being driven by one star that's just starting its life. And this is where this discovery gets really cool, because it helps settle a huge, long-standing debate. How do the biggest stars form? One theory, core accretion, says it's an orderly process, with material feeding in from a stable disk. The other, competitive accretion, suggests a much more chaotic, messy free-for-all. Well, the stunning symmetry of this jet, how perfectly straight it is on both sides, is some of the most powerful evidence yet for that orderly core accretion model. So why should we care about some giant gas cloud, right? Well, because these massive stars are the universe's factories. They live fast, they die young in these massive supernova explosions, and in doing so, they forge and scatter all the heavy elements, the carbon, the oxygen, the iron, that eventually form rocky planets like our Earth, and even us. So understanding their birth is, in a very real way, understanding our own origins. All right, for our final leg of the journey, we're going to confront the biggest questions of all, the ones that really challenge our fundamental understanding of reality itself. We are heading into the realm of the invisible. I mean, that's really the central challenge when it comes to the two biggest components of our universe, dark matter and dark energy. We can't see them, we can't touch them, but we know they're there because we can see the effects they have on everything else. So one way to hunt for dark matter is to look for its gravitational fingerprints. The upcoming Vera C. Rubin Observatory is going to map out these things called stellar streams. They're like these ghostly trails of stars left behind by shredded galaxies. Now, if an invisible clump of dark matter plows through one of these streams, it's going to leave a telltale gap, a disturbance that an observatory like Rubin will actually be able to see. And then there's the other big mystery. Back in 1998, astronomers studying distant supernovae got the shock of their lives. They fully expected to see the universe's expansion slowing down because of gravity. Instead, they found out it's speeding up. Something is actively pushing the universe apart. They didn't know what it was, so they called it dark energy. And this chart, wow, it really puts our ignorance right into perspective. Everything we know, every star, every galaxy, every single planet, you and me, all of it makes up just 5% of the universe. The rest is this dark sector, about 25% dark matter holding things together, and a whopping 70% dark energy pushing it all apart. This quote just perfectly captures this moment in science. For example, some scientists are now looking at Webb's images of these little red dots in the early universe, and they're theorizing they might not be galaxies at all, but a whole new type of object. Massive, supermassive black holes wrapped up in a fiery ball of gas, just pretending to be stars. The universe is, for sure, weirder than we can imagine. So, what's next? Where do we go from here? Well, the good news is the hunt for answers is really just getting started. This golden age is set to continue with a whole fleet of new observatories that are about to come online. While the Euclid mission is already out there mapping the dark universe. In 2025, the Rubin Observatory will start its decade-long survey, and the SPEAR-X mission will launch to probe cosmic origins. Then in 2027, the Nancy Grace Roman Telescope will go up, a machine specifically designed to hunt for the secrets of dark energy. Each one is going to give us a crucial new piece of this giant cosmic puzzle. And that really brings us to the big final thought here. It seems like every new discovery just opens up a dozen new questions. This new golden age of astronomy is revealing a cosmos of unbelievable complexity and beauty. But maybe its greatest revelation is simply the true scale of our own ignorance and the boundless, amazing territory that's still waiting to be explored.